Okay, so ice versus microwave part 2. Now, a lot of you have been saying, wait, that doesn't look like it's possible, which is okay. It's impossible science. Now, I want you to be able to do this experiment at home, so I thought I'd go over some tips. The first one is remove the glass plate. The glass plate, the silica in the glass will actually heat up, and that would melt the ice. So we don't want anything that's going to conduct heat to the ice. Same with ceramic. People that are using ceramic plates or ceramic bowls, that's actually heating up, and that's going to melt the ice. So anything that conducts heat is not good. We want to do just ice versus the microwave. Now, originally I was telling everybody to use paper plates because in my microwave that actually works. But if you really want to insulate from the sides, because older microwaves, the sides will actually heat up, you want to take a piece of paper or paper towel, fold it up, place it on top. And if you take a close look inside there, it's just sitting there. Now I'm going to end a little bit early because of the TikTok limit. Ice, it didn't melt. Why is this impossible? For levitation to occur, the upward force has to be equal to the downward force of weight. Levitation needs lift to equal weight. I am too heavy of an object for the airflow of these fans, so this is an illusion of levitation. But if we use a ping pong ball and its weight is equal to the upward force, then ta-da, real levitation. But why is the ping pong ball not flying off to the side, even when I tilt the airflow? Magic? A blast of water bottles into the air with Newton's third law of motion, water and liquid nitrogen. Liquid nitrogen boils at minus 320 degrees Fahrenheit, and it's less dense than water, so it rapidly turns from liquid to gas at room temperature. Turning water to ice on command? It's not magic, it's science. At 32 degrees Fahrenheit, water can turn to ice, but it doesn't necessarily have to. In order for ice to form, the temperature must be below its freezing point, but it needs impurities or seed crystal to build from. But if the water is pure, it's possible for it to remain a liquid well below its freezing point. This is called supercooling. Disturbing the bottle enables a few molecules to start the nucleation event, allowing the ice structure to grow right before your eyes. Have you ever wanted to know what it would look like if you could move things with your mind? Yeah, me too. Check that out. Liquid nitrogen. Banana. Oh my God. Take a look at the ruler as the sign with the numbers comes around, and you'll notice that it seems as if it's passing through the bars of the window. This is called the Ames window. Our mind associates the larger side of the window as always being closer to the camera. But that's not true. It's actually rotating in a circle. The visual cues from the different sides of the ruler tell our brain that the ruler is spinning. But the visual cues from the window tell our brain that the window is moving back and forth. This contradiction gives us the illusion of a solid object passing through another solid object. We just made a solid object pass through another solid object, and we did it with the science behind the Ames window. Of course, if you didn't understand the science behind it, that would have looked impossible. Gummy bears pass through metal, like this glass beaker.
We have our safety goggles, we have our safety gloves, and we have the permission from the fire department.
Yep.
Oh yeah.
I'm not knowing what's a fire.
By heating up the potassium chlorate, we released oxygen. The elevated oxygen with the heat causes the gummy bears to spontaneously ignite.
3, 2, 1, go for it! Whoa!
This releases more heat and more oxygen, burning hotter and hotter until the gummy bears melt through the metal.
Yo!
Yes! A gummy bear just did that.